9-4 variability. I can create and interpret box and list for box.
Excellent job, Kyle. Thank you for participating. Variability, everybody. It is a way to display how what data is.
Spread out.
How spread out data is. Good. Quartiles would be taking the data in a box and whiskers plot and dividing it equally amongst all of the data. Our quartile is going to be evenly distributed.
Yes.
No.
No, the range is not going to be equal. Is the amount of data in each quartile going to be equal? Yes. We'll talk about that in a second. Another name for a box and whisker plot is a what? Box plot. Probably not going to be constructing many box and whisker plots in your time. You're mostly going to be analyzing them. But I do believe that if you can construct them, you'll understand how they work a lot better. So that's why we're spending time constructing them. So I'm just going to skip over the directions, which you have, and we're just going to talk about constructing a box and whisker plot, like here in number 5. So we have NWEA scores, totally made up NWEA scores, in their random order. They're not in numerical order. So what we did is we took all of these scores and we put them in numerical order on a number line like so. So it looks like we had a 243, a 245, a 247, a 249, a 254, another 254, and so on and so forth. So then what we did is we found the median of all of that data, which happened to be a 254. So then half of the data is going to be below a 254, half the data is going to be above a 254. Yes, no?
Yes.
Alex, eyes up here, please. So then since we're splitting into quartiles, we need to find the lower median and the upper median. And so we had a 243, a 245, a 247, a 249, a 254. We had to find, ignore this, the median of all of that data, which happened to be a 247. So now we have a quartile here. We have a quartile here. We're going to do the same thing with the upper part of the data. We found the median at a 261. Because we had a 259, a 259, a 261, 263. So the middle was the 261. So that was the third quartile. This is the fourth quartile. Yes, no?
Yes.
Okay. Then what we are going to do, or what you're most likely going to see, is I'm going to scroll. A box and whisker plot with a number line that has equal intervals. Obviously, this one right up here does not have equal intervals because we constructed it with all of our data. Once we put our box and whisker plot with equal intervals, we can see that quartile 3 has a much larger distribution of data than quartile 1, right?
Yep.
However, does this quartile this is quartile 4, not quartile 1. Does quartile 4 have the same amount of data as quartile 3?
Yes.
Yes. It's just that the quartile 3 data is spread out. The range is much greater. Does quartile 2 have the same amount of data as quartile 3 and quartile 4?
Yes.
Does quartile 1 have the same amount of data? Yes or no? Yes. Okay, so this graph right up here is that graph, but now it just shows the range of the data in each quartile more clearly. The last thing you need to see is we did this again, but we did it with the ages of students with the last name was Smith. We constructed our own graph, and then we put it onto one that was given to us. So this was our given graph with equal intervals. And you can see that in quartile 3, we have our largest distribution of data. Yes or no?
Yes.
Okay. What is the name of quartile 1? So what would we call quartile 1? 6. It's hard to tell on this graph. But if you look here, we found our median between quartile 1 and quartile 2 at 6, so we would call that 6. What is the name? If we had to name quartile 2, what would we call it?
7.
What would we call quartile 3?
9.
What would we call quartile 4?
12.
12. And that was our, at least my cheat sheet idea, is the name of each quartile is its highest value. Questions?